Alerts in D3 are separated into two tiers, events and incidents. The reason we do this is to allow you to run automation at both levels. You can do high-level triage at the event level and enrichment and remediation at the incident level. I'll show you examples of how we can use both event playbooks and incident playbooks to process SentinelOne alerts. Before we move on to the playbook demonstration, let's check the connection status. Here we can see that the required parameters are the server URL, API token, and API version. By hitting test connection, we can make sure that we've authenticated successfully. Let's hit save and review the integration itself. Out of the box, SentinelOne comes with over 40 commands. These range from case management to data enrichment to incident response and more. The case management commands allow you to synchronize alerts and threats between D3 and SentinelOne. The data enrichment tasks allow you to gather more information on threats and agents involved in particular alerts. The response actions allow you to take action directly within SentinelOne, such as blocking indicators, updating threats, quarantining devices, initiating scans, and bringing them back on the network. The SentinelOne event playbook accomplishes two main goals. The first is to check the raw data to see if this has already been mitigated by an analyst. If it does, it'll automatically dismiss the event. The second is to search D3's incident database for any incidents that have related artifacts. If a match is found, it'll correlate the incoming alert to the existing incident. Let's see this event playbook in action. Here in the event playbook viewer, we can see all of the instances for which the event playbook has been ran. In this case, we can see that 6 tasks were executed. Initially, there was not a mitigated alert found. When we went through the correlation section, there was no matching incident related. Therefore, this alert was escalated as a unique incident. If we move on to the second instance, we can see that immediately this was tagged as a mitigated alert and dismissed. The rest of the playbook did not run. Finally, we can see here that this is another unmitigated alert, but this time a matching incident was found. In this case, the incoming alert was attached to the existing incident from this event playbook here. This minimizes the total number of incidents that your team needs to work on. Now that we've seen the event playbook in action, let's take a look at the incident playbook. Immediately when the incident is created, the playbook will check to see if a malicious or suspicious score was tagged to this alert. If it was malicious, it'll increase the severity from medium to high. Then the enrichment task will run. The enrichment section is broken apart into 4 tasks. The first 3 are nested playbooks, which you can see using the link here. By selecting the link, we can dive in to the underlying workflow. The reason we build playbooks in this modular approach is to help our clients with scalability. After the enrichment section, we move into eradication, where the analyst is presented with many options as to how they want to proceed with an event. They can quarantine, kill, or block artifacts. They can initiate scans and disconnect the agent from the network. In the recovery stage, they can get additional information on the agent, and if 0 threats are found, reconnect that agent to the network. For this demonstration, we're going to use a sample Trojan alert detected by SentinelOne. By clicking on the event, we'll be taken to the event details, where we can see an overview, the artifact behavior, and the event log. On the right-hand side, we can see a timeline of activities for this event. At 7:19, it was ingested from SentinelOne, and the event playbook found a matching incident here within the same minute. Within the overview, we can see metadata about the alert, such as the ingestion time, the trigger time, the event type, and description. By scrolling down, we can see key artifacts from the alert that have been extracted from the raw data and mapped to D3 system fields here on the left-hand side. By scrolling down further, we can see the associated incident and the TTPs detected by SentinelOne. In the artifact behavior section, we can zoom into any of them. By clicking on View Details, we can see any other related events that this artifact has been found in. Of course, if we want to dig into the underlying event, Within the event log, we'll see the raw JSON data. Immediately upon opening the incident, we can see some important information. For example, there are 2 incidents that D3 has found that matches this one. This gives us an understanding of the potential scope for this attack. On the left-hand side, we can see the TTPs and the playbook that's been ran against it. Here in the middle section, we can see the artifacts from the original event, including the username, file hash, user, and file. Below that, we can see incident enrichment information that's been collected by the playbook. For example, we can see the certain applications that have been running on this agent. The installation date, the name, the publisher, the size, and the version. This allows us to understand if there are any vulnerabilities on this device. Below that, we can see some open source intelligence results where we've searched for this IP address and found that there's no risk level associated to it. Now, let's dig into the playbook to see what happened. Immediately upon looking at it, we can see that the enrichment and eradication stages have begun successfully. In the enrichment section, the open source intelligence task has returned some results on the domains and IP addresses. We can see that no risk level has been found for either. The additional agent details has returned a list of the applications that are running on this device. The deep visibility query is built to use the process name found in the alert data to search for any other events that includes these processes. After delaying for a moment, we can pull the query ID and search for any associated events. In this case, none have been found within the last 14 days. Moving into the eradication section, we can see that the task here is on pause. By clicking into this workflow, we can see that there is a pending task. This task is also available on the left-hand side under the pending task section. As an analyst, I can come in here and answer the prompts directly without having to go into the playbook. Here, let me answer the file hash to quarantine, yes to kill, no to initiate a scan, and no to disconnect the agent from the network. Now that the remediation is completed, the recovery stages have begun and we've received information about the agent. Here we're using the get agent info command from SentinelOne to review some details about it and use these results in the following task. Specifically, we're looking for any active threats that have been found on this device. Thankfully, this device has registered 0, so now we have the option to reconnect the agent back to the network if it was quarantined before. When we're happy with this incident, we can go back to the overview and close the incident out. Back to the pending task section, this is going to give us a prompt in order to populate SentinelOne with relevant information. SentinelOne requires a threat verdict and threat status in order to update the threat from D3. Here, I'm going to mark this as suspicious and unresolved. Now we're done with the SentinelOne workflow. Thank you for watching this demonstration. If you'd like more information on D3 security and how we can integrate with your EDR, go to d3security.com.